Welcome, welcome to functions. Welcome to functions, a way of handling the complexity of the programs, complexity of the problems. So functions provide a solution to the complexity of the problems. Without functions, probably you cannot handle complex problems. So this is module 9. This is all about functions. The first topic is introduction to functions. So programming started with a monolithic program. Now what is monolithic program? Monolithic program means so we'll be writing the entire program in a single file as a single module. Also, you will not be dividing the program into parts. Basically, you will not be dividing the program into parts. That means you will not be dividing the program into what are called as modules. You will not be dividing the program into files also. So your program may be written in a single file, or it can be written in multiple files. Within a single file also, you can write the program as a single unit. So you will be writing like this: S1, S2, S3. So maybe you have say 100 lines. All the 100 lines of the program you will be writing, say, within the same program, within the same file. Even if you have say 1000 lines, you will be writing the program in the same file as a single unit. So you know that a program is a sequence of instructions given to the computer. If the number of instructions is small, then all instructions can be written in a single program. So it's not an issue. For small programs, you don't require functions. In fact, the use of functions is discouraged in the case of small programs. The reason we will see later. But if your program consists of few instructions, say 10 lines, 20 lines, etc., then definitely you can write it as a single program as a single unit. So in that case, it will be more efficient. So otherwise, it's better to handle the complexity. You divide the program into parts. But one point you have to remember is, even now, though we are dividing the program into what are called as modules, but for efficiency reasons, most of the programs, complex programs, are still written using this monolithic program concept. You are writing the program as a monolithic program. It's as a single unit. There are reasons called as efficiency. That is the reason. Actually, efficiency is one important reason that we will consider only that one. So programs are written as a single unit, monolithic program. So the execution of the instructions in a program is sequential. This we have already discussed. The physical order in which you place the instructions is the order of execution of the statements. But as the program size increases, sometimes it becomes difficult to handle the complexity. In that case, the recommended method is, actually program can be split into multiple files. program can be split into multiple files. If the content is spread across multiple files, reading them and understanding them is difficult. Remember, we are talking about what are called as multiple files. That means your program is not in a single file. So physically your program is separated. So usually until now we have written only the programs which fit in a single file. So there you can find the entire content of the program. But if you write across multiple files, so they are separate entities treated by the operating system. So you have to go from one file to another file to totally understand the program. It becomes difficult. So if the program is very large, definitely you have to go for multiple files. If the program is very large, then you have to go for multiple files. But if the program is not very large, if it is medium size, say 100 lines, 200 lines, then up to that point, probably you can go with what is called as modularity, or dividing it into parts, or dividing into functions. So where your program is partitioned, your program is partitioned. This technique is called as modularity. Remember, here you have a single file, but still it consists of multiple modules. Single file, but it still consists of multiple modules. Now what exactly is this modules or modularity? Modularity is dividing the program into parts. In simple terms, modularity is dividing the program into parts where each part is called as module actually. Modularity is dividing a program into parts where each part is called as a module. And what each module does? Each module does a specific task, or at least similar tasks. That means the rule of modularity is different tasks should be performed by different modules. Different tasks should be performed by different modules. Similar tasks can be performed by one module. It is better if the module performs only one specific task. But otherwise it can perform at least similar tasks. But different tasks should be performed by different modules. Of course, there will be certain dependency between the modules. You are dividing the program into parts, but parts are modules, but there will be dependency between the modules. Dependency between the modules. Okay, what kind of dependency we will see? And how much can be the dependency? So the general concept is your program is divided into modules where each module is a part of the program. Okay. Next, we'll consider how C achieves it, how C implements it. In C, a module is represented by a function. By a concept called as function. In C, module is represented by what is called as function. Though the interdependency between the functions should be minimum, there will be certain amount of implicit dependency as the program is written to solve a single problem. So remember, a program is written to solve a single problem. Okay, you take a problem and you write the program, but you are dividing the program into modules or functions. So there will be implicit dependency because you are solving a single problem. So collectively, that means it is something like multiple persons solving a single problem. So when multiple persons try to solve a single problem, then each will be sharing the load. So there will be some certain dependency. Of the work that is done by the different people. Similarly, because here functions are solving a single problem, there will be some kind of interdependency modules. That dependency is achieved by creating a function which provides the service and which uses the service. That means whenever you divide the program into functions, there will be dependency, and some programs will make use of services of some other some functions will make use of services of some other functions. Some functions will make use of services of some other functions. So that is the dependency here. So one will be acting as a service provider, the other will be making use of the service. The function which provides the service is called as called function. The function which uses the services is called as calling function. So you have calling function, you have what is called as calling function, So these calling function makes use of services of called function. That means actually this function calls this function, calls this function. So this is called as called function, this is called as calling function. So there will be dependency depending on the requirement. Different functions may call different other functions. So it depends on your requirement, it depends on the solution to the problem. In a program, there can be more than function which provides the service and also which uses the services of other functions. So it depends on the problem which you are solving. Also, services of a function can be used as many times as possible, which in programming terms is called as reuse. In fact, in many books you will find this. So one of the important uses of functions is reuse. That means you can write the code only once, and depending on your requirement, you can use the same code. That means by calling that function which contains that code, you will be again and again using it. Suppose you have one set of numbers to be added, you can write a function. Okay, you can pass some values and get the output. Suppose you have written a function to add two numbers only, but you have say 100 numbers, so which you will take say 2 at a time and then add them. In that case, if you divide the total 100 numbers into 50 pairs, then same code can be used, but each time we can give as input to that function two different numbers. So you are not writing the code 50 times, you are writing the code only once, but you are calling the same function, you are making use of the same function. Each time you pass different parameters. How do you identify the function? The function is identified by what is called as signature of the function. Now what is that signature? The main component of signature is function name. So every function will have a function name. Now what is the function name? Function name is nothing but valid identifier. Similar to variables, a function is also a valid identifier. So signature of the function consists of different components. The main component is function name. To reuse the function with the different sets of input, a feature called parameters is introduced. What are the other components of the function that makes the signature? We will discuss later. Okay, here also we will discuss briefly, but in detail we will discuss when we discuss function declaration. So to reuse the function with the different sets of input, a feature called as parameters is introduced. Already told you. So you can write a function to add two numbers. So each time you can pass two different numbers and then get the result. Result of addition of two numbers. So what you are passing, what you are passing, they are called as arguments, and within that function they are called as parameters. For the time being, you just consider both are equal, arguments and parameters. So whenever you are calling a function, depending on your requirement, you can pass different sets of parameters. So every time we call, we pass different sets of parameters depending on the requirement. You can pass different sets of parameters. So a function can manipulate the parameters or can make use of the parameters, and compute something which it can return. So function can also return a value. So that means whenever you pass the parameters, you can consider that parameters are the input. Parameters as input. That input can be manipulated, and also the main thing is that input parameters are used and you compute something, you compute something, and what you have computed, say in this case addition of two numbers, what it was computed, the sum of the two numbers, that can be computed and that can be written by that function, So a function has name, a function has parameters, function has name, a function has parameters, a function has return value. All this put together is called as signature. Signature of the function. Function name, parameters. Remember, there may be parameters, there may not be parameters. There can be one parameter or multiple parameters, and then return value. These three things make the signature of the function. So what is signature of the function? Signature of the function consists of function name, parameters and return value. So function name, parameters and return value. How the function invocation is achieved? Now we are saying, there will be what is called as calling function and call function, or a function can call some other function and it can use it, it can reuse it if necessary, Okay, fine, but how it is done? You take an analogy. Suppose your friend is there, your friend can help you with something. So what you do? So you call that friend. Okay, you call that friend. Now you are a calling person. Or I am a calling person. That friend is called person. Called person. What that friend can do? He can do some task. For me. So after doing some task, he may give me the result of the task. Okay. So now how it happens in the language, in C programming, how it is done using functions. So a function is there. So let us call it as f. Or function 1. Okay. So it has called another function. Say function 2. So it has called that function. Okay. Fine, but how it is done? What is required? So remember, a program is nothing but a sequence of instructions. A function also consists of sequence of instructions. So let me try to elaborate. So if it is function 1, so it will consist of different statements. It will consist of different statements. Say sum S1, S2, dash S2 sum Sn, whatever it be. Okay. And say again function 2 is there. Again function 2 is there. Similarly, the sum statements will be there in the function 2 also. Function 2 is there. Okay. Now, suppose at this point of time, a function is called. At this point, function is called. Now, what has to be done? So, when function is called, so control has to be transferred to this function, and whatever the functions that are present, whatever the statements that are present within this function, are to be executed. After executing the function, what happens? You have to come back to this point. Which point? The next statement after this statement where you have called the function. This is the statement where you have called the function. Then after executing the function, control has to be transferred to the next statement after the function call. So what is required for it? Now how do you come back? In general, if you go outside, how do you come back? How do you come back to your house or any place? Say you are staying in a lodge, you go out and you come back. How do you come back? What is guiding you? Because you remember the return address. You remember the address of the lodge, or you remember the return address. That means whenever function is invoked, this return address has to be stored somewhere so that you come back. That is done using what is called as stack. So this is a data structure. We are not going into the details of this data structure, but there will be what is called as stack. Stack is called as last in, first out data structure. So within this data structure, so you will store what is called as return address. Return address is stored. So after executing the function, this return address is removed, or technically it is called as popped. So it is removed, and then you know this address. So you go to that address. That's all. So function invocation results in maintenance of the stack, creation of the stack, pushing the return address to the stack, pushing the return address into the stack, and then popping the return address onto the stack. All these things are to be done. So that is considered as a overhead. That means in simple terms, that involves some time. Okay. That's why if you don't require a function, if your program is small, try to avoid functions, because this consumes pushing the creation of the stack, pushing the return address under the stack, popping the return address under the stack, consumes some time. That means the program execution time increases. You can avoid it if possible. In that case, your program execution time decreases. That means it executes quickly. So you should use functions judiciously. That means for a program of 10 lines, 20 lines, it's better you avoid functions. Maybe for program of 100 lines, 200 lines, you have to use functions. Beyond that, it's better you go for files. So the control is transferred to the function. After completion of the function, return address has to be popped from the stack, and control has to be transferred to the statement which is present after the function call statement. Okay, a stack is a last in first out data structure, and function use result in overhead. The general rule is, if you have few statements to be executed, then embed them. That means you don't create functions. Otherwise, make the statements as separate function. This is a stack is a last in first out data structure. So we will study about it in data structure subject. But the point is, it is something like say the trays or plates arranged one above the other. Plates arranged one above the other. Whenever you go for catering, so plates are arranged one above the other. So which one is last placed? The top one. Which one is first removed? The top one. So if you have plates placed one above the other, which one is last placed actually? The top one is the last one that is placed on the stack. Which one is removed first? The top one only. So that's why it is called as last in first out data structure. It works like that. So that is briefly about the functions. That is briefly about the functions. The concept of function, the concept of modularity. When you have to go for functions, when you avoid the functions, okay, what exactly happens when you invoke a function, that we discussed. So you can go through these references. You can go through these references if you are more interested. Okay, this is the first session about functions. So an empty mind is devil's workshop. So don't waste your time. Always try to keep yourself busy. That's the best thing you can do. If you are suffering from the so-called depression, dissatisfaction, etc. So it's better do something. Always keep yourself busy. Okay, but you have to balance what you are doing as a student, what you are doing, and what you have to do as a person in the house. Always there should be a balance, but don't waste time. Thank you.